Hi there, I'm Keith Cawley, and this is Thrive, a Bridgestone Americas podcast where we explore our company through compelling conversations with teammates across our organization. When we look at the history of a tire, there's been one constant across its innovation journey. It's pneumatic or filled with air. But as people think about mobility in the future, a frequent question we always get is when will we see non-pneumatic or air-free tires becoming common? Well, as you can imagine, it's something Bridgestone has been thinking about for quite some time. Air-free tires would be a significant solution for extended mobility, considering you don't have to worry about punctures or flats, air pressure problems, and more. Today, we'll be taking Thrive on the road to our Americas Technical Center in Akron, Ohio, to talk with Jon Kimpel, Vice President of our Extended Mobility Solutions business, and Brandon Nelson, a Manager of Advanced Extended Mobility Technology, about where we've been focusing our air-free tire development, what we've learned on the journey so far, and when we can expect to look around and see those air-free tires on the road. We hope you enjoy this conversation. Well, we are joined today in Akron on the road here for the Thrive podcast, a trip up to our Americas Technical Center in Akron, Ohio. And with us today is Jon Kimpel. And Jon, you are the Vice President of Extended Mobility Solutions business at Bridgestone. Is that correct?
It is, yeah.
Awesome.
Good to be here.
Yeah, thank you. Welcome. And with us as well is Brandon Nelson on Jon's team, Manager of Advanced Extended Mobility Technology. That is correct, right?
Yes, sir. Thanks for having me.
Absolutely. It's good to be here. Good to be out. We're in the Mobility Lab at the Americas Technical Center here in Northeast Ohio, a big footprint where we are driving the future of innovation in a variety of different ways. And one of the things that we're going to talk about today is one of the projects being worked on and led here in Akron, and that is non-pneumatic tire, which for people who don't know what non-pneumatic is, that's okay, but that is fancy tech term for airless tires without air. That is correct?
That is correct.
We're 3 for 3
You're
so
good.
far on
You're
the
good.
start. Awesome. Well, let's also start with each of you a little bit about your background, understand your journey, and how the world of air-free tires has come into your life. So, Jon, let's start with you.
Yeah, great. So been with Bridgestone now going on 27 years.
Hey.
I know, hard to believe. And started off actually with industrial products. So I came and graduated with a mechanical engineering degree from Purdue. Came down to Indianapolis and worked for industrial products, engineering, then went into sales, and then was with industrial products for about 14 years. And then I went to building products actually for a bit. And so after 20 years with Bridgestone and not doing anything with tires, I thought it was about time. And so I went to work and ran the marketing department for GCR. Did that, and then got the call, if you will, to go and be the leader for the air-free project. And now I'm in the more of an expanded role as VP of Extended Mobility. So it's been a really, really good ride.
There you go, seeing a bunch of the different points of view across the business.
Yeah,
There you go.
yeah.
Was there anything in your aspects from maybe a technical or a product side in industrial products, building products that, maybe, but that made you ripe fit for kind of this project on non-pneumatic?
Well, whether it was industrial products or building products, and even within GCR, I would say that Bridgestone's always had this drive to be innovative. And again, on the air spring side, we had that same kind of push. Even in building products, we had that same kind of push. But I would say when we started the first transformation with Gord and team, is when we really started to really invest in innovation as opposed to just being like a desire. And so taking that, when we were, for lack of a better word, just, attempting to, we were truly investing in it. So just the prior experience with that, even so part of my experience before with industrial products was the business lead for electronically controlled air suspension.
Yeah.
So where can we go and take that, do something intelligent, kind of a foray, if you will, into the mobility solution side of what we're doing today. But today we're truly investing in it, having teammates like Terrence Way and that team, Michael Johnson's team, really applying that. We're in a whole different world now, and I would say the same type of approach with air-free. Truly the investment. We'll get in later, but even like back in 2017 when we made an acquisition of some technology with it, where that primed me for just that the interest with it. And again, I have an engineering degree, but I went into sales pretty quickly.
Yeah.
And so that appreciation of taking a technology, but where can you really go and solve a market need? So my definition of marketing has been of how do you profitably solve a customer's problem, and doing that from an innovative standpoint is what I'm really passionate about. And it's also really awesome when you go and you take that, and then you have really smart people like Brandon here to actually do the technology side.
There you go.
I go and I find a problem, and he gets to solve it.
Yeah. There you go. That's the teamwork right there, the whole holistic. Brandon, what about you? What's been your run at Bridgestone, but also just general career and journey-wise?
Yeah, I've not been here as long as John, that's for sure. But
we'll all get there someday. It's all right.
Yeah, exactly.
Slowly,
I
right?
feel old now. I appreciate that, Brandon.
That was our goal. In the first 5 minutes, make John feel old.
Check.
We'll get there.
It's
Yes,
always my
done.
goal. Yeah. So I've been here about 8 years. Came out of an industry creating equipment for construction sites, and it was really kind of stagnant in innovation. And I always wanted to push the limits. And I got a call from a buddy who was working here at Bridgestone. Said, "Hey, do you want to come here? We have this program." I think at the time we could spend 10% of our time on any project we wanted. We got to choose it. And I was like, "Well, I'm in for that." And so I came here, and we've always been focused on innovation, and Bridgestone's always let me innovate. And over the past 8 years, I started off in TBR development, truck bus radial development, and sought to innovate as much as I could there, and it was always accepted by the business. And 4 years ago or so, I got the opportunity to work on airfree, and it's been a journey ever since.
Yeah.
So it's been fun to really create something new instead of just iterate on what already exists, and that's been a unique challenge. And leading a team through that has been a unique challenge as well. But we have a great team. So John gives me problems, and then I just, hand them off to the actual smart people. But we have a lot of fun doing it.
Got a good process down that we're working.
Absolutely.
We're working everything through.
Push it downstream, right?
Well, and we so we'll talk about the topic a little bit. And John, we talked to Christine Reagan on an earlier episode this season, and she's on your team of Extended Mobility Solutions, and that was focused on retreading, which I understand will come into play here. But how does, when we think about Extended Mobility Solutions, for those who may not understand the dots that connect, how does air-free tires really fit into that world, and how it fits into all the things your team is working on?
Yeah, I can even go and with the extended side and even across the E8, and one of those E's being an E extension. So with one thing you want to do is how do you extend, and this even gets into the sustainability side of how do you reduce in terms of the actual how much material that you use. And the longer you can get a tire to last and to run, and even I'll get into the retread side of how long can you get the casing to live for, that has a huge both a sustainable benefit from the environment as well as from a business standpoint. So it's a great TCO, total cost of ownership, for a fleet, but also you're not going and taking materials and having to build something new, if you will, in terms of the whole carcass, the whole casing. You're just retreading it. So in terms of extending the life of that casing. And part of what we looked at in terms of the whole value proposition is what's causing a casing to not last as long as what we think it should. And underinflation is a big one. Crown punctures is a big one. And so if you go and you take and you remove that variable of air, again, you remove underinflation and you remove the issue of the crown puncture, so therefore extending it. So it's and I'd also say in terms of the whole value proposition, again, being good for sustainability as well as for business, that the more that you can go and retread something, the better off you're going to be. So retread is actually a really critical part of the value proposition of airfree. This is not going to be a less expensive alternative if you're adding material to it. So just intuitively, it's going to be more expensive. So you really do need to have retread to be part of it, to be part of the value prop.
Well, and as we look at making an air-free tire, I mean, the case is clear for the benefits from a performance and like you said, extension. Like it's a little bit of safety. You're not needing to worry about the maintenance and punctures and being left on the side of the road or be put in dangerous situations. So in that sense, you're like, yeah, we should be making air-free tires. And then, we got materials out there. You make it without air, and it's a big brick, and you put it on a car and you roll.
Yeah.
But it's very, what are the things that you need to worry about then, and why is this so hard, I guess, Brandon, to solve that problem, to make an air-free tire that is viable, that's the performance, and what type of performance do we need it to deliver?
Yeah, it's a very challenging problem, and one of the things we don't realize about air tires, if you want to call them that, right? Pneumatic tires, is that the air does 80% of the work in carrying the load. And it's very efficient, and it's free, and it's lightweight, and there's all these benefits to it. So when you try to take it out of the tire itself, you have to replace that with something. And so the materials are now doing the work. And we have a lot of really strong, really great materials out there to choose from. but
Yeah.
they're not that strong yet, right? So we're at a unique moment in time, I think, where the materials and the technology are starting to come together to make this possible, but it's still at the cutting edge. It's the tip of the spear, and so it's very challenging to make it all work together.
Yeah, and it's a nice like little science lesson, I think, for people seeing air as part of the mix and the properties of what makes the tire performance and it's whatever deliverable in that sense. We usually just think we need it to fill up so that it rides better or something, but it's all part of the holistic tire experience.
Absolutely, absolutely. It's critical.
Yeah. Well, we ventured in. I think some of the people who've worked for Bridgestone for a little bit maybe saw the initial air-free conversation in Japan. They introduced an air-free bicycle a couple of years ago, and we're trying to perfect that. We've done air-free tires through the Tokyo Olympics in Japan on some small Toyota vehicles that kind of looked like Segways, and they were kind of personal mobility things. So at a very small scale, low speed, low weight, right? We're looking at air-free here in the Americas in a little bit of a different way. How did we, I guess, assess where we wanted to focus air-free, and how did we end up where we are, and where are we, John?
Yeah, it's a great question because and Brandon asked us at the very beginning, like, did we really have to pick the most difficult application?
Why not?
Yeah,
Let's
exactly.
challenge ourselves.
Because I thought there was a market there.
That's right.
But yeah, as you said, Bridgestone Japan working on for the bicycle side. And in fact, the technology we bought in 2017 was from Polaris, as in like the ATV company. And they were using air-free for a ATV application, a lot of military as well. But again, it was, each one carried 800 pounds, something like that, Brandon?
Something like that.
And went 35 miles per hour. But we then took a look at, okay, where is there truly a market need? You can go after in terms of what's technically viable with, some kind of technology today. Even like on solid tires, like you'll see on telehandlers, et cetera, you'll see these solid tires that they kind of look like there's holes in them, and there are, but it's more for just to help with the molding process. So there's some things we could do, again, low speed applications. But we took a look at, okay, what about the waste application? What about underground mining? What about, again, truck or trailer? What about autonomous? What even about, do we use this as the next version of run flat? Mm-hmm. And then we said, okay, well, what problems does air-free actually address? And then what's the addressable market? Because even on the trailer or TBR application, it's not going to be every single trailer is going to have it. We first said it's probably going to be more the sophisticated fleets that truly measure a total cost of ownership or cents or dollars per mile. So we went and segmented that. And then that's when we decided, okay, we think first off, we have a technology that's viable that can get into that trailer application. And we even picked the trailer side because about 60% of the emergency roadside situations are because of a trailer tire issue. It's very poorly maintained, underinflated, et cetera. So that's why we went and picked the trailer side. What's nice is the fact that, from what the impact of a drive application or a steer, the trailer doesn't see that as much. So it's a good place to start off with the trailer that we can then take to the drive and then to the steer. Technically, though, again, there's about 120 psi of air. So there's a lot of pressure and a lot of work that air is doing. So I can't say that Brandon went and said, that's perfect. That's exactly, thank you very much, Kimpel, for that recommendation. But we started off in the very beginning of don't short putt.
Yeah.
Meaning don't go and just kind of like go what's easy. Go with what there's an addressable market for. And if we can start off there, it's also difficult. We realize that. But then it's easier for us to go and take that base technology and even the material science and the modeling behind it. And then, okay, now let's talk about some of these emerging OEs as an example, or how about the waste segment? We can go and then, trailer isn't the final destination, it's the start.
Yeah.
But it gives us a base technically where we can go to other places. But yeah, it was not, the team's been awesome and they'll take the challenge. They did not short putt.
Yeah.
But it wasn't.
No, it hasn't been an easy ride, but it's been a good one. I mean, where we started with the Resilient Technologies tire that we purchased, I mean, it was a great tire for that application, and it works to this day. Unfortunately, you can't scale it up.
It's not a mass market.
Right, yeah. If you scale that up to the size of a truck tire, TBR tire, there's some major issues immediately come to the fore. And we saw that really quite early on when we started testing that tire, but it gave us a springboard to jump to that next technology. Where do we need to go? And that trailer tire being our North Star, it really got us to aim higher. And so we know we can scale that technology down, but it's really hard when you have a solution that's set for something of like a lower energy density to scale that up and be successful.
Well, that was going to be one of my next questions. Was we talk about real investment in innovation. This in particular is probably not something you get right. You're not going to get any of this stuff right on the first try. No. So what has this kind of iteration process been like? I guess, how long have we kind of been working, and what have been the stages, I guess, of learning, of pivoting, of evolving the strategy forward, or the approach?
Yeah, it's definitely been a journey. And as hindsight's always 20/20. Sure. So you look back and you're like, well, why did it take so long to figure that out? But the reality is, until you do it, until you start diving into the problem, you don't know what you don't know. And so in the beginning, it really looked like quickly iterating and creating prototypes and getting out there to test physically so that we can realize what are these main hurdles we're running into. And over the years, it started to progress into maybe taking a little bit longer between iterations, although the team's probably going to laugh when they hear me say that. They still feel like we're going 1,000 miles an hour, which we are, but we are changing how we design. We're being more meticulous with how we design. We're utilizing our virtual tools in a way that we have never used before, and we're creating just a stronger technology every day.
How do you I guess keep the team? It's got to be a mindset, right? And we've talked about this with a couple of different people, and more often in that innovation space where you have to set different targets that you're meeting. I mean, I get distracted by chipmunks and squirrels and everything, and so what did I do today? Let's check it off the list. That's my achiever and my strength performer stuff right there. But I mean, how do you do that as a mindset, right? That you're like, we're kind of in this for bad pun long haul. Mm-hmm. And you're going to go through some stuff where you're going to have to stop and maybe take a step back to then go a couple of steps forward. It's got to be grueling at times, but the payoff, I guess, is what drives you, right?
It does, I think, and it depends. Different people have different personalities and how they approach work, obviously. But, there have been seasons of just the team is fully on board, fully in it. And then we hit a wall, right? Which we have many times. We've had to scrap projects that we've worked for months on, and people put so much effort into, and then all of a sudden, that didn't work, right? And we have to totally change course. And in those times, I think it's important for us to remember that end goal, remember where we're moving towards, and look to what we've learned even in that failure. Because even in the midst of designing something that you end up putting on the shelf, you've learned a significant amount on how to design that part of the process or whatever it might be that we can apply to the next time we do that. And that next time is going to be that much easier and that much faster and that much better.
No. That was one thing early on, though, of we didn't want the team to think of it as a failure. Yeah. Now, if you keep on doing the same thing over and over again, okay, maybe I'll call it that. But it was more about a learning.
Yeah.
And so that whole, the learn fast part of it, and we talked about, treating these more like roundabouts, if you will, or decision points, not as a gate. And to go from, early on, it was a thermoplastic, so plastic web. Okay, what did we learn from that? Okay, that doesn't work out. Okay, well, what material properties do we need? So we went around the roundabout, came back, and then moved forward. I'd also say a couple different things. One, using outside expertise. Mm-hmm. So to go and look at some, within the aerospace industry, other parts of the automotive industry, material science. Yeah. So all this in terms of the co-development with it and using outside expertise. Brandon and team have done an excellent job with that. I'd also say Brandon's demeanor and just in general, if you want to be an innovator, the highs and lows, if you can go and manage that and be more even keel, he's done an excellent job with that. Be very pragmatic, objective about it. But also the modeling side is, I'll let you talk about that, but you've built virtual, amazing amount of virtual prototypes in a short period of time.
Yeah. And when we say you, he means Dr. Ben Ramai and Brad Plaza.
Exactly. Yeah, we're going to name drop Ben and Brad.
I got to give them some credit, obviously.
Yep.
Yeah. The virtual tools have been huge in how we've developed. And over the past couple of years, we've really started to utilize AWS, Amazon Web Services, and their cloud-based infrastructure. So, right now we utilize on-prem resources, or we have historically, we have a set number of servers that we can run our models on. And these models that we're creating now are huge. And we're talking about all of the elements in the tire, plus a full suspension system on a truck, plus hitting objects on the roadway. And it's a large model, but that team has been able to develop it in a way that it runs quickly, it gives us reliable results, and then coupling that with Amazon, we're able to run thousands of iterations in weeks. And that's game changing, because before we're running, an iteration here, we're thinking about it, an iteration there, and we would never have found the solution because you're just wandering in the dark, so to speak, right? So now we have this ability to map the whole space, and all of a sudden we can say, oh, there's where we need to be. And that's what we've been doing, iteration over iteration over iteration, for the past year or so. And we've gone from a tire that had a rolling resistance of 30. And if you're familiar with tires at all, I mean, that's unheard of. The tire actually would light on fire at that point, right down the road.
Not fire, a thermal event.
And we've proven this in testing, yes? That would be a fun thing to do. Yeah, sure.
So the first tire that we did was pretty thick, and it lasted maybe minutes.
But now we're at a potentially, right, industry-leading rolling resistance, even among pneumatic tires. So that's a feat. That's impressive.
And I guess when you think about all the things you have to address, what have been when somebody says, what are the challenges of a non-pneumatic tire versus a pneumatic that you have to address? What is that list, and how do we go about solving them?
Yeah, that's great. And I think it depends on which market you're trying to approach. It really depends on the application. And I think this is where what we're doing is different than what we see other competitors doing in the marketplace right now. And so what we're really focused on from the beginning is honestly rolling resistance, is getting a tire that can go down the road without lighting on fire. I should stop saying that word, right?
No, it's something we're going to avoid, and we're committed to avoiding
That's right,
it.
we're
Fantastic.
avoiding that. But I mean, getting a tire that actually is fuel efficient, and that's one of the biggest drawbacks when we start to use materials to carry the load. Naturally, most materials that flex enough to be a tire are going to be lossy, and they're going to drag as you go down the road. So we focused on that from the very beginning, going to lossless materials. But as you go to lossless materials, a lot of what happens is you start to have trouble handling impacts, handling natural undulations in the road. And so that's been a lot of our focus over the past few years is making those materials which give us the efficiency we need also be robust enough to handle what they're going to see out in the road.
What do you hear from partners when you go out? I know a couple of years ago, it was right before kind of the COVID hit, we were starting to showcase, I guess, this path to some of our commercial partners and tell them that this was coming. What's been kind of that reaction and conversations that you get when you talk to our customers?
So especially on the fleet side, very, very engaged.
Yeah.
To the point of when can I have it? I need it now type of thing. Give me updates. Sure. And that's whether it's like on the application that we're going after. So very, very engaged. They see the value prop, even at a higher price point. They see that return on their investment. And then there's other areas, like I said, we can go and put this in the last mile side. We can go and put it more in the emerging OEs, robo-taxis, et cetera. So we're getting a lot of pull as well of when can I have that technology for these other areas. And that's something that we need to, because you can drown an opportunity and you can lose focus on what you mentioned, Keith, of how do you remain focused on and solving the problem. So we need to map out, okay, when we get that baseline of material science and modeling, then we can go to other areas because there is quite a bit of interest out there.
Yeah. Well, I guess to that question then, in general speaking, I don't know what timelines and what proprietary plans are, but where are we in the journey to make that available to customers? Yeah.
You want to answer so you're accountable to it, Brandon?
No.
So
we're putting it down. It will hold as ink right here. Exactly. This is all of it, right?
Yeah. Paulo and Nazar. So actually, this year, later this year, we're actually going to be testing again at TPG. And then
the Texas Proving Ground.
Texas Proving Ground, yep, exactly right. And that's after doing thorough lab testing here within ATC. And we even start off before then with a component level validation as well. So we build up to a full scale. And then next year in 2023, we want to do more fleet trials. And then by 2025, we're doing more of a controlled launch with those fleets. So it's becoming very, very real.
If we were to look at then industry-wide and zoom out kind of to wrap up the conversation of what does the 5 to 10 years down the road, maybe not just for a commercial trailer trucking application, but is this, I guess that's the natural question, right? Is like, when will I get an air-free tire on the car I drive? Like, is that a realistic path in the industry moving forward, even just not just us, but just as you see that? And then my other question was related to like what we do with mobility solutions, and we're talking about putting sensors in the tire and making it more connected. Does an air-free structure of a tire open up more or different or better opportunities to embed sensors and do that as we move forward into the future?
So I'll do in terms of the 10 years. The big with in terms, I do think you have to look at it from, almost looking at it with the E8 in mind, in terms of it does help you from an ecology standpoint, an efficiency standpoint, extension standpoint. I would even go and suggest even from a motion standpoint of what air-free can provide you. And that is going to go and extend to other areas. I do think, especially initially, even within a 10-year span, you'll be looking at still more fleet applications. But those fleets are going to get into, again, like robo-taxis, people movers, more the autonomous side. I can see that, that playing a big role. And we've seen that even from feedback from NHTSA. So part of this is regulatory. How do you go and approach it? And they're very, very interested because, again, NHTSA regulatory authorities are pushing for autonomous from a safety standpoint. And, the maintenance of the tire, when you start removing a driver, you only have limited maintenance when you do have a driver. You remove that, and that decreases that much more. So I do think that there's going to be a push in that end for air-free technology. But you can talk more about that.
Yeah, I mean, we are definitely looking at air-free holistically from a solutions business, from a sustainability side. Yeah. And as we see, the advancements we're making in our casing health models, for example, as we see the advances we're making in our wear models, we do expect to work to implement those over the years into air-free. I don't know if the structure necessarily lends itself to any sort of better methodology, so to speak, but it has its own unique challenges and unique needs. And one of the things that we are exploring even actively is how we can make sure that when your air-free tire is having an issue. Right now, air actually allows you to know when your pneumatic tire is having an issue, and so having that predictive maintenance capability and that, I guess, early warning system is something that we're looking into.
Gotcha. Well, you've heard it here that within the next year, we'll be in robo-taxis, autonomous driving cars that are on air-free tires, which is the next stage to flying cars, which the team is also working on. So this is great.
Absolutely.
It's really good to see all this come together. Fantastic. But thank you guys both for the time. I mean, it's a fun conversation. It is a topic that I think a lot of teammates have always been curious about. If you look around the industry, it's like, where is this a more tangible part of the future, I think, to a lot of people, because that would be a next step in tires. But tires have kind of been the way that they are for a century, it seems, right? So this would be quite a step forward. But Jon, thanks for the time. Brandon, thanks for the time. Appreciate the conversation.
Yeah, thank you.
Been fun. Thank you.
Now, non-pneumatic tires are just one of the many key extended mobility concepts we're continuing to focus on at Bridgestone. As noted, one of the others is retreading, which would be closely connected to the air-free tires that we would be bringing to market. If you want to learn more about retreading or revisit the conversation, you can check out our episode on bandag and retreading from earlier this season. Of course, you can find that wherever it is you prefer to listen to podcasts. While there, remember to give us a rating or a review, and remember you can also watch all of our Season 3 episodes on the Bridgestone Americas YouTube page, or you can reach us via email with a question, topic idea, or share some feedback. Just send a note to thrivepodcast@bfusa.com. Thanks for listening. I'm Keith Cawley, as always, reminding you to keep on keeping on, and remember that at Bridgestone, today, tomorrow, together, we thrive. Be good, everybody.